Hello, everybody, and thank you for joining us at SnykCon. My name is Tomas Gonzalez. I'm a partner solutions architect at Snyk. And today with me to present this developer-first security experience on OpenShift is Dave Muir, a partner solutions architect at Red Hat. Dave, why don't you let our audience know who you are?
Yeah, thanks, Tomas. Hello, everyone. Really excited to be part of SnykCon. So as Tomas mentioned, I'm a partner solutions architect at Red Hat. I'm focused on our security ISVs, typically around OpenShift, and we've got some great partners like Snyk. So Tomas, I'll hand it back to you to start the presentation.
Thank you, Dave. So for our audience today, we have a really cool demonstration set up. So to set the stage about what we're going to be showing you today, we have a sample application. It's a Node.js application that relies on a Mongo database. It is being continuously delivered from the GitHub repository where it's hosted into OpenShift, exposed externally via a route. And we do not recommend running this application in production uses because it is very poorly configured and very hackable. So today, what we're gonna narrow our focus down into is we're gonna narrow our focus to the configuration aspects of this workload on OpenShift. Show how the Snyk Kubernetes monitor, which is a Red Hat certified operator available on the Operator Hub, can be used to monitor the OpenShift workloads for vulnerabilities, insecure configurations, and take those configuration elements and help developers prioritize vulnerabilities in the workload accordingly. We're going to be showing how the way Snyk presents information on workload configuration helps developers spend less time finding and fixing the issues and more time getting to business and actually developing. So with that, that's enough for slides. It is time to tempt the demo gods, and let's get our demonstration started. So first off, as I mentioned, our application is available on GitHub, just github.com/snyk/goof. And this is a very, again, reiterating, very poorly configured and very hackable application. It's meant to be used as a playground. We even have documented exploits that can be used to demonstrate some of the real world risks of running a vulnerable application in production. But for today, I'd like to start. Dave, can you show us the application running in an OpenShift environment? Tell us a little bit about what OpenShift is.
Yeah, absolutely. So OpenShift, I think everybody knows, is Kubernetes, but it has a ton of services added on top of it. So if you wanted an enterprise scale Kubernetes cluster for your company, and you started with Kubernetes itself, the upstream Kubernetes, it's great, but you would have to add in all these services to really make it enterprise grade, especially all the security services. We don't have a lot of time to go over all the different services that OpenShift offers, but I'll name a few as we go along. But as you can see here, one of the things that OpenShift provides is a developer perspective. You'll notice here I'm at the top right of the nav here, I'm at the developer perspective. One of the things it has is a topology view, and you can see all the workloads that are running in this project. So I'm in the user 4 project. It has a goof pod that's running here, and you can see, you can go into the details of the pod, get the route. This is an actual running application, as you can see here. And then you get a bunch of other details like monitoring CPU usage, memory usage as well. It's a very nice view for developers as they deploy apps to visualize their workloads within OpenShift. There's a ton of other features as well. One of the things I wanted to mention is you can see Snyk Monitor is deployed in this cluster. This is a namespace configured Snyk Monitor integration, and that was deployed in this cluster through the Operator Hub. Tomas mentioned that a little bit earlier. And if you go to OpenShift's Operator Hub, which you will only find in OpenShift, you'll see all the Snyk operators. And this one is actually installed. So if I click out of that, go to installed operators, go to all projects, you'll notice the Snyk operator is already installed here. The Snyk Monitor instance, which is the integration, looking at those workloads and sending those results to Snyk, has been installed in each of the user projects that are created in this cluster. So that's a quick view of OpenShift in this running application. Now, Tomas, I'll turn it over to you to let you show the security posture of this very poorly configured application.
Absolutely. Thank you, Dave. So as Dave mentioned, we have the Snyk Kubernetes monitor deployed into OpenShift. And what that's doing is it's looking for workloads that Snyk can report configurations and vulnerabilities against. These can be deployments, these can be deployment configs, replica sets, daemon sets, whatever governs how that workload is meant to be scheduled into an OpenShift project. And for each monitored workload, we will report two things from our Kubernetes monitor. So first off, we'll report the configuration of the workload. You could see this workload is passing the check where it's not running in privilege mode, but it's failing these checks for you're not setting CPU limits. We're also not setting memory limits. We're not dropping excessive capabilities. So from a configuration standpoint, these checks help prioritize the second thing that our operator detects, which are the security vulnerabilities associated with that workload. So for each of the vulnerabilities, Snyk presents what's called a priority score. And the priority score is, besides gathering information on the availability of an exploit, the availability of a fix, it's also synthesizing that with the configuration information from our operator, so to help prioritize the vulnerabilities. For example, a vulnerability with a privileges attack vector, if the workload is configured to not drop excess privileges, that's going to get bumped up and assigned a higher priority score. If the vulnerabilities attack vector is availability attack vector, where the resources are a critical piece, and you're not setting CPU and memory limits, that vulnerability is going to get prioritized higher. So for all the imported monitored workloads, we're finding both the configuration elements as well as the security elements. Now, in the interest of presenting developer-first security, how would we now go about fixing or remediating some of these issues? Let's start with the two examples of the CPU and the memory limits, since these are two that are very similar in where the fix is applied. So if you go to the Snyk projects view, by importing the GitHub repository where the application is hosted into Snyk, we're able to see the deployment manifest files that control how this application is deployed into OpenShift. When we open this, we can see all the different configuration elements that could be improved in our deployment YAML, including running without a CPU and memory limit. So these are the two of the checks that failed in our operator's check. If we expand each of these vulnerabilities, Snyk gives us information about what the issue is, what the impact of that issue is, and how it can be resolved. In this case, by adding a CPU limit and then subsequently a memory limit to the workload in the resources limits part of the pod spec. So with that, let's dive a little bit about how we go around applying this fix, in this case, into a running application on OpenShift. So Dave, can you show us how we could apply this?
Absolutely, yeah. And before I do that, I wanted to talk a little bit about some of the features by default that OpenShift provides related to resource limits, as well as what we call security context constraints. If you take a look at my screen here and we go to pods and we see that the goof pod is running, I'll take a look at the YAML. So this was deployed from the deployment config that's being scanned by Snyk. And I'd say around, let's go to line around 26. It might be tough to see, but there's an applied security context constraint of the type restricted. So OpenShift by default comes with several security context constraints, and by default, every pod that is deployed gets this restricted security context constraint. And there's various things in that definition, that YAML definition of this SCC, that govern how that pod is run or what conditions that pod must run in. Like, for example, the first one of them is it must have SE Linux turned on, or it must have SE Linux configured. And you could see that probably a little bit down here in the YAML file 162, where it has security context and there's some SE Linux options. You also see things like capabilities that are dropped. So there's various security type features and capabilities that are applied automatically to these running pods. That's great. You don't see that in vanilla Kubernetes. However, from a developer perspective, this is obviously great for operations folks because by default, they don't have to worry about certain things. But from a developer perspective, you definitely want to know and set good practice to add this information to your deployment files anyway. Right? This is always good practice to move security information and education left in the life cycle, and that's exactly what Snyk is giving you, that ability to teach your developers to be able to add that information to their deployment configs. The other thing to note is resource limits. So if we look at administration down here in limit ranges, as a OpenShift administrator, OpenShift by default doesn't come with limit ranges, but you can absolutely create one. And in fact, this cluster has an automatic configuration. If you're creating any new projects through the UI, like let's do SnykConf project, that will create a limit range by default. So here's the limit range that was created by default. So you can absolutely create some automation around limit ranges, and this will be applied to any deployments, any running pods. But for this demo, in the user 4 project that we're using, there were no limit ranges found. I can add one, but the Snyk config is scanning the deployment. So we'll actually go into that goof deployment, and right in the YAML, we can find the resources section. I believe that's around 139 or so. Yep. And we'll add limits. And forgive me, I need to do a little bit of YAML editing. And it might be a little bit small, but I added just a limits under resources of CPU and memory. And I'll go ahead and click save here. And goof has been updated. If we quickly go to pods, you can see one pod is terminating and another pod has started in its place. So with that, hopefully if all goes well, we'll go back to Tomas and he can show us in the Snyk UI how that was applied and updated.
Absolutely. Thank you, Dave. So coming right back to where we left off from the issue view, if we return to the projects and we find the workload that Dave edited, that would be user 4 deployment apps goof, and we fire that up, we can see that now with the changes that Dave has applied, the CPU and the memory limits are marked as a pass. So Dave was able to apply a hotfix to a running application. OpenShift tore that down and spun it back up. And now it's passing those configuration checks. Now, with the capabilities Dave mentioned, you might be wondering what's happening. Like if OpenShift had applied CPU and memory limits as part of those limit ranges to the pod, why was this originally flagged as a fail? And that's a matter of looking at the file that the developer submitted to OpenShift. OpenShift has those controls to ensure that the pod itself is created with the appropriate limits. But if the developer is not specifying the limits in their deployment configuration, they're still deploying a misconfigured workload, even with all the controls OpenShift has. So we'll still call it out here until the YAML file that is updated under the covers is running the workload under the covers, is updated to include the CPU and memory limits. What we showed today was how, with the information from the Snyk Kubernetes monitor deployed into OpenShift from the operator hub, then you're able to take that information, look at the infrastructure as code results in Snyk, apply a fix to the running workload, and patch the vulnerable aspect of the workload without ever having to commit code to source control. That's what would come next. So you fix the issue in the production environment, then the idea is the developer would take this information, go back to their IDE of choice, fix the YAML file, redeploy the workload, and you no longer need to do this again.
That's right. You don't want your OpenShift admin to, modify your deployment configs like I did in your running cluster, right?
Yeah, that's not ideal. Yeah. And you don't want somebody telling you, hey, your workload's not correctly configured, so I had to put safeguards into place. It's good, but it's not ideal. This is kind of embarrassing to the developer. So with that, just a little recapture of what we just demonstrated. We'd love to hear what you thought. We, of course, made this presentation quick, focused purely on the infrastructure as code configuration elements. So please let us know what you thought. This is all part of a much larger workflow Dave and I have put together for the Red Hat product demo system, where you can work through finding the open source risks, the container base image risks, the infrastructure as code risks, and then work on remediating those bits as part of a larger interactive workshop. So if you'd like to see that workshop in person or request it for your company, please get in touch with either Dave or myself. And of course, if you're using OpenShift, find Snyk in the Operator Hub. Give it a shot. Deploy that into your namespace. Start reporting issues into the Snyk UI. See what we can fix for you. And of course, Snyk is also available in the Red Hat Marketplace, powered by IBM, for purchase. So, Dave, anything you'd like to add?
I think you hit the nail on the head, Tomas. That was a great demo and really quick. I enjoyed it. Enjoyed being part of SnykCon. So I wanted to thank you again. But yeah. Like you said, we do these workshops all the time. Typically, they're in person. Lately, they've been virtual, so we could do both. But let us know. Very, very hands-on type workshop, which help you learn the concepts that we've been talking about today.
Awesome. Thank you all for attending.
Thanks. Bye.